Hello guys, hope all of you are doing great. In this part of the video, we'll be learning everything about functions in Python. I'll be telling you what are functions, what are the different ways of writing functions in Python, and also I'll be telling you what are the advantages of using functions in a program. I'll be showing you examples from where you will automatically understand, okay, these are the reasons for which we need to use functions in our program. And you will start using functions in your programs. Okay then, let's begin today's part. Okay, whenever you want to use a function in Python, the first thing that you have to do is you have to create the function. And how do we create the function? For that, you have to make use of this keyword def, that stands for define. We are defining a function sort of, okay? And then after writing the keyword, what you have to do is you have to give a name to the function. Say for example, here I am giving the name as f1. You can call the function basically anything, say abc, xyz, function 1, add, subtraction, multiplication, or whatever the name you can think of. Okay, and after that, as part of the syntax, you have to write these open and close parentheses. See here, the name of the function is your choice, but these open and close parentheses you always have to write. No matter what name you keep to the function, that is not a problem, but this part you always have to write as it is. Clear? Okay, and after that, you also have to write this colon. That is again a part of the syntax. Okay, and after that, inside the function you have to write the body of the function, and this body of the function is nothing but a block of code that you want to execute whenever you are actually executing that function. If it's not very much clear right now, don't worry, but for the time being, what you can think of is these functions are nothing but there are some separate programs. So this body of the function, you can think of it as a program now. Now, whatever the code that you want to write or you would want to write inside a program, you can write the code here based on your necessity. Okay. So when I say you can think of functions now as a separate Python program, what you can do is inside the body of the function, you can write any valid Python statements. So for example, I write here a print statement. Say our function whenever okay, I'll be coming to that point. So right now you can think of like, okay, the body of the function is only one print statement. That's all. Now see here, these two lines of code, in these two lines of code, what I did is I created a function whose name is f1, and the task of the function you can think of, the body of the function is nothing but it is the task of the function from an abstract view. The task of the function is to print a line of stars. That's all. Done. Clear? Okay, done. Now see here, I have just created the function. Now let's see what happens if I try to execute this function. If I click on this play button, it is executed sort of, but the thing is that we are not seeing the output that we were expecting, because you see here, you know, in Python, if you execute a print statement, so whatever you specify inside that print statement, it displays the thing as it is on the screen as an output. But here, sort of this, it is not doing the thing, isn't it? Although we have this print we have executed, but it is not showing us this line, this line of stars on the screen, isn't it? See here, I'm executing the program, but it is not showing me the output. The reason here is that when you create a function, this definition of the function is something like, you can think of it is a formula or it is a blueprint. Okay, by default, the Python interpreter is not going to execute that blueprint. What you have to do is, if you want to execute that blueprint of the formula, what you have to do is you have to explicitly mention that thing to the Python interpreter. And how do you do that? You do that by calling the function. Technically, we say that calling a function. And how do we call a function? Just by writing the name of the function and then these open and close parentheses. That's all. Now see here, what we did here is we created a function, and immediately after that we have called the function. It means we are instructing the interpreter, now you execute the function, execute the body of the function whose name is f1. So now if I execute this program, you can see here, this f1 is getting called, and as a result, whatever it is the code that you have written here inside this f1, that is executed, and as a result, you can see the output as expected. See here, had there been two lines inside this function, there could have been easily, isn't it? So said this program contains two print statements, or they could contain any valid Python statements, as I said. No, okay. Let's for that sake, let me declare a variable here. Say I is equal to 90. Okay, and then what I do is I is equal to I plus 100. That is, initially I stored 90 in I, then I added 100 with that previous value of I, which is 90. So 190 will be stored in I, and then what I do is I print the value of I on the screen. Okay, so now my body of the function is these 4 lines. So whenever I now call this function f1, what it will do is it will execute all these 4 lines from top to bottom. So as a result, what you'll be seeing is this line of stars plus 190 on the screen as expected, isn't it? Clear? Okay, and this is how actually you can create a function. Now here we are creating the function, and then we are executing the function. Now see the advantage here. This code, whatever you have written here, whatever the function that you have created, it is not that you can call the function only once. You can call the function as many times as you want. As many times as you want means I can call it twice, I can call it thrice, or what I can do is I can do something like I can use a loop for I in range say 3, that is 0 to 3. I want to call this function f1. Even inside a loop, you can actually call a function. So basically you have to create a function only once, but the thing is that once it is created, you can call it, you can use it as many times as you want. That is certainly an advantage, isn't it? You should be able to appreciate that thing. Okay, let's now execute this program and see the output. See here, what I did is I am calling this function 3 times first, manually 1 1 1, and then inside this for loop again I'm calling this function 3 times. So totally 6 times I'm calling this function. So 6 times I should be able to see this output on the screen. Let's execute it and see. If we count 1 2 3 4 5 6 times, it is showing me the output. Clear? Okay, this is how actually we create a function and then we make use of the function. Okay, if you have understood up to this point, then you have understood the basic concept of a function. Rest of things will be only some specific details about functions. Okay, that those things are also important certainly, but my point is that if you have understood this up to this point, then technically you people know about functions, and now it is time to know about the details. Certainly there are a few things that certainly you need to know about a function. Understood? Okay, let's now move forward a bit and try to see something more about functions. Okay, now when I call a function in this way, that is I said you right, that is writing the name of the function and open and close parentheses this way, this particular thing is called as calling a function. This is the definition, this is the calling. Now here you see the calling of a function. When I call a function, what I do is I write the name of the function and then I write the open and close parentheses. Now these pattern, this thing, writing something in this way should be familiar to you, isn't it? See, let me show you an example. So when I write, say for example, print statement, you see here I say print statement, but see the similarities of writing print and calling this function f1. See here, print is a name and then these open and close parentheses are there. No, it's the same. See here, this assume f1 is print and then these open and close parentheses, isn't it? So yes, inside these parentheses this hello is there, but for the time being ignore it, and then you will see, okay, these two things are very much similar. They have a name and then open and close parentheses are there. It means what? This print is nothing but it is a function call, right? Yes, print is a function call. Similarly, you see here, say for example, we have a list and where we have these few elements there in the list, okay, say 89, and then we want to compute the length of the list. And how do you do that? We use this len function and then we pass L inside it, and then we usually store the length in this variable, say n. Now here my point is, see here, this len thing, I write here len, it is a name certainly, and then open and close parentheses are there. It means what? It is also a function. Clear? Okay. Now here, although I said they are functions, print is a function, len is a function, but here you see, here we have seen two things about function. One is like the definition of a function, the other one is the calling of a function. But when we use print and len, you see that we have used only sort of one form of the function. That is, we are only calling the function. We never have defined anywhere. We never had to actually write anything like def print and then some code, or def len and write some code, right? That is, we didn't have to do like write the body of the print function or the body of the len function, isn't it? Then you might be thinking, okay, if the body we didn't write, then how come the Python interpreter knows like what to do when we call this function? How come the Python interpreter knows what to do when we call this len function? Where is this definition part? Okay. Now, the answer to that question is that these functions like print and len, these functions are called as built-in functions or inbuilt functions. Okay, these built-in or inbuilt functions are nothing but the definition of those functions are already there with the Python interpreter. That is, the developer of Python interpreter have already written the code for these functions, print and len, like that. Okay, and that's the reason that these functions are called as built-in function or inbuilt functions. So these are like something like inbuilt features. Say for example, let me give you an analogous example. Say for example, you buy an Android phone. There are some built-in features there, right? Or say for example, you are using a laptop where Windows 10 or Windows 11 operating systems are there. So along with the operating systems, many different program comes, like say for example the paint program, for example the video recording software, and all these things comes, right? So those are sort of built-in softwares in the operating system itself. But say for example, now you want to do video editing. For that, and whatever the video editing software it is given with the operating system, you don't feel like sufficient. Okay, for your task at least, those things are, say for example, not sufficient. So what you do is you install a third-party software in your program. So those are not built-in softwares, but you have to install them, right? Similarly, the same analogous example you can use here also. So by default, with Python interpreter, a set of few function comes, not a few, quite a handful function comes actually, and quite a handful features are there with Python interpreter. And such functions are like this. A few examples of such functions are like print function, len functions, like that. These functions are inbuilt functions in Python. It means the definition of those functions are already there, already they're written for you in Python interpreter. You don't have to write them again from scratch. Okay, so directly you can call them. Understood? Okay, these are called as built-in functions. Then if they have a name, like if all those functions for which we don't have to write the definition, only we have to call them, then those are called as inbuilt functions. Then what are these functions for which we have to write the body of the functions by ourselves, and then obviously we'll be calling them by ourselves. So these functions are called as, yes, user defined functions, because these functions are defined by us. We, now the user of this Python interpreter, sort of the programmers, we define these functions, we create these functions according to our own need, and we use them. So for that reason, these are user defined functions. Okay, now if people have understood what are these user defined functions and what are these built-in functions. Okay, when I said about built-in functions, let me talk about, let me give you one more examples of built-in function, sort of. Okay, so for example, if you remember from one of my previous video where I talked about mathematical functions like computing the value of sine theta and cosine theta, so let's use them one more time. Say for example, we have an angle which is like 3.14 by 2, that is 90 degree almost, and then what we want to do is we want to compute the sine value of this angle A. And how do we do that? For that, we used something like mat.sine, and then we pass the angle, that radian value there, and say for example we want to store the result in say for example sine theta st or any variable. Now see, if I try to execute this program here, we know that there is a function called mat.sine. You have used it, but still it is showing us the error name mat is not defined here. Now what is the here, say sine is not a built-in function, sort of. Okay, if you want to use sine, this particular function sine, then what you have to do is you have to include a separate file with your source code. And how do you do that? Yes, we have to make use of this import statement that allows you to attach an external file at least with your code. Okay, and that external file can contain the definition of a few set of few functions. Okay, so one such external well-known external function file is this math module. Okay, when I say math module, you can think of modules are nothing but there are some external there are some external independent Python files where definitions of a set of functions are there. Okay, so when I write import math, it means that file is also now included with your program. It means whatever the functions, the definition of those functions are there, they're also there sort of with your program. So this time if I write now math.sign, the definition of this function will be found by the Python interpreter. Okay, because this file is already there, so it will find the definition of this sign function inside this math module. So it will not complain anything now. Okay, and it will if I print now, if I print, certainly then only it will show us the result on the screen. Clear? Now that is the importance of, now it should be now more meaningful to you when you write import statement. Got it? And why we need to do that, one reason for that. Understood? Okay, and there is another reason actually that I showed you this example that I'll come to in a moment. Okay, maybe right now. Okay, now if you have understood up to this point, now let's move one step further again. Okay, and what is that one step? Now see, I said you that there are similarities between this writing the between the way that I wrote this function f1, that is when I call this function f1 and when I call this function print. But I said you that for the time being, if people ignore what I wrote inside this print function, like if you ignore what we wrote inside that print function, then only they look very much similar, right? But if you, as soon as you look at them, like what we wrote something there inside the print function, I mean inside these open and close parentheses, then it is certainly a different thing than not writing anything here, right? Now let me tell you what are these actually. So whenever you write something within these open and close parentheses of a function, when you call that function, these are called as inputs to the function, or more technically these are called as arguments to the function. Arguments to the function, or you can think of like these are inputs to the function. If you change this input, the same function will behave differently. Certainly, say for example, if I write here, if I give the input hello to print function, it will display hello on the screen. If I give flower to print function as input, so it will show me flower on the screen, isn't it? Same thing is true here. If I give this list as an input to this len function, it will return me 3. Here I have not displayed it, but you should know 0 1 1 2 3 3 elements are there, so it should return me 3. But if I give a different input, say different list, say for example here I store a string, say flower, in that case it will return me 4. That is, if I print here and you will get a 4, right? So based on the input, the output changes. Based on the input, the output of the same function changes. The same len function is sometimes telling me 4, sometimes telling me 3, based on the input that we give to that len function. Clear? Same thing is true about the sine function also. I mean, the same sine function will give you here almost 1 if we specify the input as 90 degree. But if we give the input as say 180 degrees, so it will be giving us like 0, almost 0 as the output. Almost 0. Why did I say? Because this inaccurate value of this pi. Okay. But I guess if people got the point now, that is, whenever we write something within the parentheses of a function call, that something is actually an input to the function. There could be more than one inputs also, but those are actually input to the function. Now let's see how we can write a function that can take input when the function is called. Okay, let's see an example. Say I write here another function. Say for example, I define, first thing is I have to create a function. That part is exactly same. That is, you have to make use of this keyword def, and then you have to give a name to the function. Then you have to write open and close parentheses. Then you have to write this colon, and then you have to write the body of the function. And see here, the body of the function certainly depends on the program that you are writing or the problem that you are trying to solve. Okay. So here, say for example, now the difference here is this, the difference of this f2 and this f1 that we want is that this f2 should also be able to take input when the function is called. And if it is the case, then what you have to do is in the definition itself, you have to mention that thing. And how do we do that? Say for example, when we call this function f2, we want to specify two inputs. Say for example, the first input we call as a and the second input we call as b. Okay, and then inside that function we make use of those inputs. Now see here, when I say inputs here, I just wrote some names, and you know, right? I mean, say for example, if I write a equal to 3.14, what is this a? This is a variable. When I write l equal to a list, this l is a variable. N equal to something, that n is a variable. So similarly, this a and b, these are nothing but these are also some variables. Okay, you'll be seeing in a moment like how these variables are used. Okay, now say suppose inside the definition of the function or inside the body of the function, we want to use these inputs. Okay, and how we can do that? Let's say, the simplest use is like we want to display whatever those inputs, we'll simply display them on the screen. Okay, say for example, print a and print b. Okay, and that's all. This is a function that I have created as a programmer, and the name of the function I kept is f2, and also I specified that whenever this function is called, the two inputs should be provided to the function. Okay, now once that is done, once we have created the function, now it is time that we use the function, we call the function. So if I now want to call the function, you know how to call a function, right? Yes, you have to write the name of the function, and then you have to write the open and close parentheses of the function, I mean, as part of the syntax, right? But see here, this time if I try to do this like f2 and open and close parenthesis, what it is saying me is it is like the Python interpreter is sort of objecting. It is not executing the program, and it is reporting us that f2 missing two required positional arguments. I said these are called as arguments or inputs, arguments a and b. It means, see, in the definition of the function you have written, you specified that whenever the function is called, in the call, from wherever you are calling it, you have to specify two inputs to the function. But since we didn't specify any input here, Python interpreter is objecting it. You see here, calling a function and the definition of the function, they are sort of tied by an agreement. That is, calling of the function should always match with the definition of the function, and you cannot break it. You cannot break the agreement, and if you break the agreement, then Python interpreter will be objecting it. It will not execute your code properly. Got it? Okay, so now if you want to now stick with the agreement, then what we have to do is we have to write we have to give two inputs to the function. So for example, the first input I give as a 12 as a number, and the second input say 12, but a string 12. Any input basically. See here, these variables we can store in a variable basically anything. It could be a number, as a floating point number, it could be a string, or even it could be a list. Right. Now let's see what happens when we execute this function now. Now this time no problem. You see, f2 I passed here, like I said passed, but I'll be coming to f2, and then I specified 12 and the string 12, or any basically. Okay, so whatever I give as input, this function, see here, this 12 will go to a, the first input that you specify when you call the function. It will go to the first variable that you specify in the definition, and the second input will go to the second variable. But see here, you might be thinking, what will happen if I write here third input? That will be a problem. It will violate the agreement. See, you have to specify as many inputs as you have specified in definition, not less, not more, exactly same number of inputs. Okay, done. Now as a result, see, 12 will go to a, 12 will go to b, and print a will print the number 12 on the screen, print b will print the string 12 on the screen. Clear? Understood? Okay, then. Now also I said you that these are variables. So if these are variables, then we can store anything there. So if we can store anything here in a and b, it means from here we can pass anything. What I mean by anything? Yes, instead of this string, I can pass here a list also. Say, I create a list. For simplicity, I create a list here. L is equal to a list 1, 2, 3, say. And what I do is, inside this function, when I call the function, what I do is I pass the number 12, and also I pass again I'm saying pass. Pass means what? You are passing something as input whenever you are calling. That is, whenever we write like the inputs to a function, when we call the function this way, we call it like, okay, we are passing 12 to the function. It is passing, right? We are passing 12 to the function, and we are passing the list to the function. So where this 12 will go? This 12 will go to the first variable. This L will go to the second variable. It means when we execute this function, when we call this function in this way, and when the interpreter executes this function, it will see A as 12. It will see B as this list. So when it tries to print A, it will print 12 on the screen. And when it tries to print the list on the screen, it'll just print the list on the screen, right? When it tries to print B, it will actually print the list on the screen. Okay, let's see the output here. See, 12 and 1, 2, 3. You got it? So that's how we can specify. We can write a function that takes input from the, like whenever the function is called. Got it? So now it should be clear, right, to you, like, what is this actually? It means what? It is a print. The definition of the print function in such is written in such a way that it needs at least one string as an input, or means at least one, one element as an input. See here, it could be anything. This print function also, here also you can write like, now instead of writing print n, you can also write print l. Even I wrote it here, right? I mean, print b. So when b is a list, it is basically printing a list. So basically in print function, we have to specify, we have to give an input. The same input will be displayed on the screen as it is. Okay, so that is an input to the functions. Similarly, when you write len l, it means that you should realize that definition of the len function, it needs an input, and that input should be of type collection. And if it is the case, then it will return you the length of that collection. That is how many elements are there in that collection. Understood? Okay, now you people have learned like how to write a function, how to call a function, and also how to write a function that accepts input whenever the function is called. Clear? Okay, done. Now let me move one more step further. This step also you have already seen or used at least. Now what is this step? Okay, let me show you an example, and from there it will be clear. Now, say the step that I'm going to tell you is, okay, let's see. If I write here print, and if I write hello, and then again if I write print and I write world, don't worry, up to this point yes, print hello and print world. You know the output. If I execute this program, yes, it will print hello and it will print world, and these two print will print these lines on two different lines, right? Because whenever, by default, the characteristics of print is such that after printing whatever it has to print, automatically the cursor comes to the beginning of the next line. That is, in the next printing will always start from the from the beginning of the next line. And again, after printing whatever it has to print, automatically at the end it inserts a new line character. So automatically the cursor comes to the beginning of the next line, right? And as a result, you can see hello world, they are coming in two lines. Now you also know that if you have to print this hello world on the same line, then what you want to do is you want to override this default characteristic. That is, after printing hello, you don't want the cursor to go from here to here. You want this cursor to remain somewhere here, right? And how you can do that? You can do that by specifying one very special input whose name is and there you will write some character that you want to display after hello. If you want to display a space, you'll be writing a space. If you want to display a dot, you'll be writing a dot. Okay, and by default, what is this and character is? By default, if you don't write anything, say for example, if you don't write this and at all, then by default that character is the new line character, and that's why this cursor comes to the beginning of the next line. So if I write hello and then n equal to nothing here, so hello world will come like together, because after hello I removed the default new line character, and I said that okay, it should be nothing now, nothing should be printed. Okay, but if I give a space here, you'll be seeing a space in between these two words, hello and world. Clear? Now what my point here is that you see here, sometimes we are giving one input to this print function. Now print world, only one input we have given, but here you see we have given actually two input to this print function. Print hello, and then we are writing a comma, and then we are writing and equal to something. But this is one input separated by comma, certainly. This is one input and this is another input. How come it is true? Because I said you that you cannot call a function, you have to call a function always with exact number of inputs. So if it is the case, then what is the exact number of inputs that this print function needs? Is it 1 or is it 2? If it is 2, then the writing this way is wrong, and if it is 1, then writing this way is wrong. But both of them are right. You know that, right? I mean, if I can execute them, then how come it is possible that sometimes it takes 2, sometimes it takes 1, and also at the same time I'm saying you that you have to call the function with exact number of inputs that is there in the definition of the function. Okay. That is one point that you should keep in mind for the time being. I'll be disclosing the reason in a moment, but before that, another thing I have to tell you: the way that you specify the input. See here, I wrote here and is equal to a blank space. That is, I first sort of specified a key or a name, and against that I'm storing some value. Not like F2 L2 comma L. Not just by separated, not just separated by comma. Here this and equal to something. This and equal to is not part of the the thing that the part of the input that I want to specify. This is my input, isn't it? So that is another thing that you have to keep in mind. And both these two, now I'm going to reveal the reasons and how you can do the same thing with your own user-defined functions. Okay, let's first come to the first point. Like, how come both these two things are true at the same time? Okay, for that, let me write another function. Let me create a function. Say, for example, define f3, and then here I write. Okay, let me give it a name. Okay, just just to break this monotonousness. Okay, I'm calling all the functions f1, f2, f3, and all. And also, let me give you some sort of practical, something like some real world, the feeling at least of some real world example. Now say, for example, we know Newton's second law, F is equal to ma, right? So from there, we know like the gravitational force on an object whose mass is m. What is the gravitational force on an object whose mass is m? Yes, F is equal to m into g, isn't it? So let's say we write a function whose task is to compute the gravitational force acting on a mass. So let's call it, say for example, gravitational force, long word, gravitational force, say F, let me write in capital. Okay, gravitational force or gravitation force or something. I guess if people understood what am I talking about, right? And see here, this function, say for example, it needs two input. One, F is equal to m into a or m into z. So you need m to be specified and a to be specified, right? And then we write the block of the code as like F is equal to mass into acceleration. Done. And then at the end we print F on the screen. Clear? Up to this point, no new thing I told you. I wrote a function, I defined a function whose name is gravitational force that needs two input, and it when you execute it, it actually computes the product of m into a, and that thing it prints as the force. Like we interpret that thing as force. For the computer, it really doesn't mean anything like what you interpret this thing as. Is it the force between two objects or whatever it is, it really doesn't care. Okay, now for us it is the force. Now let's make use of this function. Okay, so if we want to make use of this function, then what we can do is we have to call that function. So let me call this function here what did I do? Yes, now I'm calling this function gravitational force, and then I'm writing here, say mass is, say for example, 100 kilogram, and a say we know it is on Earth, the acceleration due to gravity is 9.8 meter per second square. So here I'm writing 9.8 acceleration. Okay, and that is the force, gravitational force, and not on that object. And say we now call that function. Okay, if we call this function, then what will happen? This 100 will go to m, and this 9.1 will go to a. As a result, when we write f equal to m into a, 100 into 9.8 will be computed. So 100 multiplied by 9.8 will be 98. That will be stored in f, and printf will print 98 on the screen. Okay, let's now see 90. Oh, sorry, maybe I did a mistake. 100 into 9.8. Is it 980? No, it is not 980. Something is wrong. Gravitational force 100 into, oh sorry, yes, right, it is not I'm sorry, 980. Obviously 980. Okay, but whatever, you got the point, right? F is equal to ma. Basically it is computing 9.8 into 100, 980 or whatever. Yes, this number is being displayed on the screen. From point 1 is coming, it is just because, like, it is trying to, this automatically it is trying to rounding off these floating point numbers. Okay, that's why this 0.0000001 is coming. That for the time being you can ignore that inaccuracy in the computation. Okay, now if I give different inputs, say for example only 9, then it will be giving me 900, clear cut, right? If I give here 10, it will give me 1000, clear cut, isn't it? Okay, done. Now what my point is, my point was, up to this point, actually my point was that how come both these two things can be true? I mean, sometimes one, sometimes two. Yes, now the point is, see here, why did I bring this example, specifically this example, why did I pick up? When I say compute the gravitational force applied on a mass, you immediately know what is the acceleration due to gravity on Earth. That is the basic assumption. If I don't say anything about that value, you assume that the value is 9.8 meter per second squared. So it means sort of it is the default value, isn't it? So what we want to do in the code itself, that we don't want to, like, every time, we might not want to every time specify this a value. By default, if we don't specify anything for a, what we want this a to be is, we can write it directly here. Say by default the value of a is 9.8. That is the default value of a. And what does it mean? Well, like, when it should take the default value, then when we don't specify anything about it, when we don't say anything about it, it means we mean the default thing, isn't it? Now say, if I now execute this program, it will not object anything about mismatch of argument and the called version. Here, although it is a mismatch, is not it? I have specified here only one input, but here in the definition it requires two inputs. But still, it is not a problem, because for one of the input we have already specified a default value. That is, if that value is not specified, then you take this default value. Where is the problem? Right? And as a result, you see here, you are seeing sort of the earlier output here when we specified 100,9.8, 100,9.8, and if we don't specify that 9.8, basically you will be seeing the same output. But suppose now we don't want, we are at moon or somewhere where the we want to compute the gravitational force on moon, and we know that, right, the gravitational the acceleration due to gravitation is less there. Say for example 2. I don't know about the exact value. Say for example 2. So in that case, it will be it will override the default value 9.8, and it will consider this value as 2. So as a result, this 100 will go to m, 2 will go to a, overriding this 9.8. So as a result, 100 into 2 is 200 will be displayed on the screen. And that's why, and that is the way, you see here, writing this way is also right now, and writing this way is also right, isn't it? So everything is true. It's true that you have to specify exactly the same number of input that you have written here in this definition. That is also true. And also, it is also true that sometimes you can actually sort of do something that which feels like we're breaking the law. Here, like with this one, like sometimes you're calling it with two inputs, sometimes you're calling it with one input. But you should realize that this mismatch is only possible because of these default values. That is, there must be some default values set. Then only these things are possible. And see, you already have felt that, right? I mean, print hello and equal to writing this space, and if I don't write it anything, basically what is the default value? I said you, it is new line. So writing it in this way is same as not specifying this thing. Actually, by default it is default new line character, so you don't have to explicitly specify. That is, for example, here writing 100,9.8 will exactly produce the same output as writing only 100, because that 9.8 is already the default value. Got it? So now that thing is cleared now to you. Okay, if it is clear, then the other thing, like here, here see, although this mismatch thing I explained you, that sometimes two, sometimes one, the same function, how it is working because of this default, value thing. But still, I didn't say anything like. There is one more thing that I have to tell you. Where did I write? Yes, here actually I wrote, but I erased that. N is equal to say now a space. Other thing I have to say is that, see here, this mismatch of inputs. I said sometimes two inputs, sometimes one input. That thing is explained to you. Now another thing that I have to tell you is, see here. Here I have said two inputs and one inputs, but here also two and one. But the thing is that when I specified this input, I also wrote like n is equal to something. That is, instead of directly specifying the value, I also specified like where this input should go, to which variable this input should go. What I mean by this. Okay, for that, again, let me create another function. Okay, let me create another function. I don't want to modify any of these previous things. Say, and again, more and more I write, more and more people will feel like, okay, you will see more and more of writing me a function, and you'll be like, automatically your mind will absorb those things. Okay, that's what I think. Okay, now DEF, I think it is true also. Okay, anyhow, machine learning thing, right? Machine learning means what? Like, if you have ever heard about it, main thing about machine learning is showing the computer more and more and more and more and more examples, and letting the computer know the things, underlining pattern from those examples, without actually telling the computer the rule of the games. Just by showing the computer only the examples, we expect the computer actually to learn the underlying rules. And it happens with human beings also. More and more examples we see, we learn actually from our examples only, isn't it? From childhood. If you see a baby growing up, you will see that this thing is very much true. The baby actually learns from the environment just by looking at or observing different examples. And that's why different babies learn different things, because they are lots of examples are there on this in this wild. And some of the babies look at some examples more closely, and some of them are interested in some other examples, some of them are interested in some other examples, like that. And that way they sort of develop their own personalities. That's what I think. And that's very much a very similar thing which happens in machine learning also. Okay, but that's a separate story. We can talk about it later on. And why did I bring this machine learning is that if you're learning Python, then you already have you already have done that prerequisite to go to machine learning, at least in today's world. Because in today's world, machine learning, yes, certainly it is about the algorithms, internal techniques, but one crucial part is that the language that most of the machine learning programs or programmers we use is Python. If you know Python, you have the prerequisite. One very big and like major prerequisite that you have acquired is the language of machine learning. And the rest of the things are, obviously, if you want to know it, then you need to know about those algorithms, techniques, concepts, all these things. We'll talk about it later on some other day. But yeah, now let's come to this point. What my point was, yes, the difference between writing this and that, right? And for that, I was about to create another function, and I was telling you like, why am I writing these functions again and again? Okay, let's now again come back here. Then let me again go back to our old default pattern of function names, like F4 here I'm calling it, and let me write here some inputs here. Say for example, I write here f name one. These are variable names, as you know, like variable names are your choice. You can write any variable names as you want. It is true here also, but I'm trying to give here some meaningful names. If you can guess what this f name could be, you are right. This is first name. That stands for first name, and then middle name, and then last name. But there is no special thing about these names. Okay, you could have easily called them as F, M, and L, or anything X, Y, and G. No problem. Okay, but you'll come to know in a moment. Giving meaningful names are good idea actually. Okay, for that, what I do is like, okay, this function whatever it needs 3 inputs. And what those how am I going to interpret those? As a programmer, I'm going to interpret those inputs are like the first name, middle name, and the last name of a person. And inside this, say I display a welcome greeting message to along with the name of the function. So for example, I write here welcome plus plus, and I give a space. Already I have given a space, and then I will be writing fname plus a space. Plus means, string concatenation. I'm just going on combining, welcome, first name, middle name, last name, like that. Okay, m name plus and the space and l name. Okay, and as you can guess, what am I doing here is welcome, whatever the first name, then space, whatever the middle name, then space, whatever the last name. Okay, done. And this is my function definition I wrote. And now what I want to do is I want to make use of this function. Say for example, I call this function f4 and I have to specify 3 inputs there. I can easily write 1, 2, 3, no problem. As I said, how you interpret this thing, the computer has it doesn't worry about how you interpret this. Even if you pass 1, 2, 3, it will not object that thing. It will consider 1 as fname. It will store 1 in fname, 2 in mname, and 3 in l name. But here it will certainly object because you cannot add numbers with strings, so certainly it will object. But what I can do is, yes, I want to pass 1, 2, 3, but in the form of strings. That time it will not object. Okay, like this. Okay, if I execute it, then see, welcome 1, 2, 3 is coming on the screen. But rather than doing this, let me write here a valid name. Say welcome Thomas, okay, and Alva, and the middle name, and the last name is Thomas Alva Addition. Okay, and this time if I execute, you'll be seeing welcome Thomas Alva Addition. Great. Now my point here again, what is this writing and is equal to? Okay, and there what we can do is that, okay, here you see when we specify according to the definition of the function, it needs 3 inputs, fname, mname, and lname. And here we have specified 3 inputs. The first input will automatically go to the first variable. The second input will automatically go to the second variable. And the third input will automatically go to the third variable, right? And okay, now what happens if, now what you can do is, another thing that you can do is the same function you can call in another way, in this way. So f4, but this time what you do is you also can specify, you can sort of, now you are not relying upon this default ordering. Okay, so explicitly you can mention, okay, that I want that this value to go to fname. Okay, and the value is say Thomas. Okay, and what I mean is this: Thomas should go to the variable fname. So obviously there should be a variable in the definition whose name is fname. Okay, then only it will work. Fname equal to Thomas, and then also you are specifying that, okay, middle name and the last name. Say let me bring the last name here. L name is equal to addition. Okay, EDIS, addition, maybe like this. Okay, and then the middle name is m name is not like this. M name is equal to, say, Alva. Now see the order. I didn't maintain the order. That is, first I specified the value of f name, then I specified the value of l name, and then I specified the value of l name. That is not a problem if you specify the input in this way, because you already have specified, like, this should go to f name. Wherever that f name is, it will go to that f name. This should go to l name, so wherever this l name is, it will go to that place. This should go to m name, so wherever that m name is, it will go to that place. So no confusion for the Python interpreter also. Okay, and that's what we're doing here actually. So we don't know exactly where this, and we might not know exactly in which position that AND input is. Okay, so in that case what we can do is, but we know that there is an input whose name is AND, and then we want this space to go to that particular input. And that is the importance of specifying these inputs as meaningful names. Okay, had they been called this AND input as, say, XYZ, then remembering it in, like, okay, we have to write X is equal to something, and what does that X mean? Someone has to tell you, okay, that X means this. But if you write AND is equal to like that, and intuitively you get an idea, okay, it means something to do with the AND, and automatically as a human being we can actually get to the point directly. Clear? Understood? Okay, done. Now you know now what is the meaning of writing n is equal to this. It means we want the value of, so in the definition of the print function, there will be an input, there will be a variable whose name is n, and to that variable, input variable, we want this space to go, sort of. Got it? So these are called as keyword arguments. What are them? Keyword arguments. Okay, if the name is not clear, let me make this Python interpreter say you the name. Now I said you here in a moment. I'll come to that point. I say you here that when you write like this input should go to f name, there should be one variable here whose name is f name. Suppose I do a mistake here. I don't write f name. Okay, I write here f name 1. That time it will throw you an error. Python interpreter will be confused. Okay, Thomas should go to fname 1. So it will go to the function definition. It will search, okay, is there any fname 1 here? No, no one is fname 1. Again, since it's a program, it's dumb actually. It's not human being. It will not be knowing, okay, maybe the user has done some mistake. Fname is there, fname 1 is not there. Maybe fname itself is fname 1. It will not do that deduction. It will simply throw you an error. I didn't get fname 1 there, so this is your error. This is your error. See, F4 got an unexpected keyword argument. That's what I was saying. These way of specifying the inputs, these are called as keyword arguments. Keyword arguments means like key value pair you specify. This is your key, this is your value. So these are keyword arguments. Okay, and why you got this error? Because unexpected keyword argument fname 1, unexpected keyword argument. It means this thing is not there in this family, and this is an unknown member of the family, sort of. Okay, but as soon as you remove this one, that error will be vanished. You are back on track. Exactly the same output, but the order is not maintained here. You are free to write the inputs in any order you want, as long as you specify which input should go where. Clear? Understood? Okay, and new people have learned about keyword arguments also. So you have learned from here almost all the things. I mean, now you know the meaning of writing this, meaning of writing these two different ways of writing the same functions, and is equal to specifying like this. And all this you have learned, right? How to create a function. See, again, you know how to create a function, you know how to call a function, you know how to write a function that takes input from the user, and also you know how to write a function where you can actually specify some default values, and also you just have learned how you can call a function. See here, now the definition of the function is as normal as it was previously. Okay, I mean, no special thing here. Only thing is the way you call them, it is different. Sometimes you can call in this way, sometimes you can call in this way. And this is true for any of these functions. Say for example, just consider this f2 a comma b. Okay, it prints a and b on the screen. So here this f2 is there, so I don't have to define it anymore, but what I can do is I can call that f2 here. Say f2, we know that there is an a, there is an b, but I reverse the order. In b, I specify the input as, okay, this e, I just write something here. This is b, and okay, this was at second position, and I write here a is equal to, this was at first. I write something there, okay? But the thing is, you see, I reverse the order. B, what I specified is now is that, okay, these inputs should go to B, these inputs should go to A. I don't know in F2 definition which one was first, like B was first or A was first, or which one was where, okay? But if you see, then we'll know, okay, A was first, B was second. Now you'll see here, if I execute this program, you'll be seeing, okay, this was at first, that is which one is coming first? A is coming first. Like, see, it is showing you print A. It is the output of print A, and this is the output of print B, and that's what the code says, right? First you print A, whatever it is in A you print, whatever it is in B you print. So in A, what we stored? In A, we stored this was at first. So as a result, this was at first. In B, we have stored this was at second. So this was at second. Understood? Okay. Understood? Then it's good. Now, if people have learned, we are almost done. I mean, you have learned most of the things about function. Now, there are certainly a few more things. Okay. These are there. You have to know them actually. one more thing. Okay, let me now tell you about there are another two ways of actually specifying inputs to a function. But if you know up to this point, like, you know, if you have understood up to this point, then that will be sufficient for you to use functions quite fluently, quite comfortably in your programs. But still, you people will see somewhere, you know, someone writing functions in different ways also, and there are two different ways other than all these you will be seeing commonly. I mean, usual. There are two different ways possible. Only two different ways are left. Let me tell you people those two different ways. Okay, and okay, let's do it in this way. Now see here, I said you that, you know, a function, you have to, like, a function, you can create a function that can take you know, as many inputs as you want, and but the thing is that you have to write the name of all those inputs. Like, you know, if your function has to take like 10 inputs, then you have to write all those 10 input names. Maybe your function takes 15 inputs, then you have to write all the names of these 15 inputs. But for some reason, assume that when you are writing the function, you don't know exactly when you are going to call the function, like how many inputs you'll be passing. It might happen actually based on the situation. So you don't know exactly like how many inputs this function will accept. This function should take maybe 1 sometimes, maybe 0 sometimes, maybe like to say 20 sometimes. Okay, so since you don't know, what you can do is at that time what you can do is you can make use of a function that is like in a way that we call as like arbitrary number of inputs. Let me show you an example. Again, I create a function def and then say call it f5. But what I want this function, what is a special thing about this function is that this function should be able to take any number of any inputs. And how is it possible? I mean, how can I write, like I said you that the number of parameters, input parameters should be same as the number of inputs that I specify in the definition. So any number of any inputs, how is it possible? It is possible if you make use of these special symbol in front of the name of the input. So suppose I call these inputs as A or B or anything I can call. Say I'm calling it say inputs. But there is no special thing about this word inputs. Okay, the thing is that this star, okay, let's call it A. Okay, otherwise inputs you might think it's a keyword or something. No, nothing like that. The special thing is about this star. Okay, it is not an arbitrary choice here. It is a meaningful thing. When you write star in front of the the variable name inside the definition of a function within this parenthesis, it means that that function is capable of taking any number of inputs. Okay, let me show you here. And then what I do is I simply print here whatever it is that is in A. Simply I do that thing. Okay, and let's now make use of this function. See what I mean by it can take any number of any inputs. Okay, say I now call that function f5 with let's try what happens when I call it with no inputs. Okay, so if I say no input, see here basically print A is printing nothing. Basically A is nothing. You know, in A it didn't specify anything actually. And these open and close parentheses, like what is this thing is, if you are familiar with tuple is a built-in data type in Python. Although I didn't say anything about tuple in my previous videos, I was about to tell, I mean in the coming videos certainly I'll be talking about tuples, and another one is dictionary. These are built-in data types in Python, and for the time being what you can think of is you can built-in means what? The way list is a built-in data type. List I told you about, right? All details about list. So the way list is a built-in data type in Python. Similarly, tuple and dictionaries are two very commonly used built-in data types in Python, and the tuples are specified in this way. For the time being, you can think of tuples are nothing but they're very much similar to list, at least. Okay, for the time being. Now, if they are very much similar to list, then you can see here it's a blank list. In case of list, you'll be using a square bracket, like a pair of square bracket. Here you're using a pair of parentheses. Don't worry if you don't know anything about tuples or if you're hearing the term for the first time. But at least you should be knowing, okay, what is the meaning of this? What is the meaning of writing a star in front of the argument name? Is that function can take any number of any input. Let's now call the same function f5 with maybe two inputs, say 1, 2. Okay, or maybe f5 sometimes with like say 3 inputs, 6 comma 7 comma a string, say for example x y t or something like that, right? And let's execute this function. So f5 first time no input, second time 1 and 2, and third time 6 7 and x y t. It's a tuple. Like yes, you can see the similarities of with a list, like a list with 0 elements, a list with 2 elements, a list with 3 elements, and the way you can access the elements of a list, here also you can do that. Say for example I want to I want to print the first element of the tuple on the screen, like that. And this time I will not be calling it with f5 because there is no first element at the time. So I'll be calling with 2 inputs, 1 comma 2 and 6 7 xyz. And here it is showing me f2. What is this? I did a mistake here, sorry. print print a1, and if I execute it, you can see that f5 1 comma 2, the output here is a will be this tuple 1 comma 2, and then this is printing 1 comma 2, and then a of 1 is what? A of 0 is 1, a of 1 is 2, so 2 is coming. Similarly here 6 7 and x, this tuple when it is stored in a, when it will be printing 6 7 and xyt, 6 7 xyt, the tuple print a, and then print a of 1 of this tuple. A of 1 is this 7, so 7 is coming on the screen. Clear? Understood? So this is called as like any number of, okay, let me write it here in this, any number, arbitrary number of inputs, actually arbitrary number of inputs, basically any number of any inputs, arbitrary, right? You don't know exactly what is the specific value. Okay, done. And that's all. This is at least you should be knowing like what is the meaning of writing this star in front of an input parameter, any number of any inputs, basically. Okay, done. Now there is another way, and this is the last way, people can write a function. Okay, and this is also important, and at least you should be knowing, because this will involve knowing at least something about dictionaries. Okay, but don't worry, again, if you have understood this one, then that one also you will be understanding. And that other one is that you see here, it is very much similar to this one, like any number of any inputs. But the thing is, when the user calls the function, the way here it is, the user will be, or that is, when you call the function, actually user means the programmers, okay, not the like the user of the program. It is the writer of the program, okay, the programmers. Here in this context, user means. Now when a programmer now call the function, then they will be calling it not in this way, they will be calling it like this way, okay. It is same, but I think you want to call the function in this way, but at the same time you want the function to accept as many inputs as you specify, sometimes 2, sometimes 0, sometimes maybe 100. Okay, got the point? So this thing is called as like arbitrary number of keyword arguments. Okay, the same thing, but arbitrary number of keyword argument. And how do you do that? Same thing, define f5 and sorry f6. Here I'm writing another function here, and now I want this function to take any number of keyword arguments, and I'll be writing basically 2 stars there. Okay, and then I'm calling it, say for example, b. I can call this thing as anything. Previously I called it a, so I'm now calling it b. Okay, and then I'll be writing here a colon. It says that this function f6 is capable of taking any number of any inputs, and also when you call the function, you have to specify the inputs in terms of like key value pair, like that. What I mean, you see here. Say for example, for the time being, I simply print b the way I did it previously here, simply printing a, and then I print say b of, now not 0 1 2 3 4, I'll be specifying a key here. Say for example b of what should I specify? Say blood group. You might be thinking, from where? Don't worry, I'll make it meaningful very soon. B and B of blood group. Okay, now my point is, you see, if I now execute, certainly nothing will happen. I just have created, I didn't actually use. Now I'll be using. Okay, what how you're going to use it? Yes, okay, f6 is my function. F6 I'm calling, and then I'm specifying inputs here. And how do I can specify any number of inputs. Again, I'm repeating, any number of inputs, but the input should be in key value format. So I'm writing it in this way, f6, and then I'm writing name is my key, and my value is, say, Mr. X, and my another key is, say, age. Key I'll be writing in this way, age, that is without any double quotation or something, is, and then I'll be writing, say 42, or maybe I'm writing, say, for example, height, height, and here, say, for example, 5 point maybe 9 or maybe 10, and then I'm writing blood group. You see the same word here, I wrote blood group here. These are my keys. Okay, blood group is equal to, say, for example, A positive or something or whatever. Okay, now setting, this is one way of calling the function, and if I call it, then what it will do, first it will be printing all the everything that I passed to this function, this entire thing, and this entire input will be received in the form of a dictionary. And dictionaries are also inbuilt data types in Python, the way tuples are, the way lists are. Okay, in my video series till now I have discussed only about lists. I didn't say anything about tuples and dictionaries, which I kept for my future videos. Certainly I have not yet reached that point, but very soon I'll be reaching that point. But for the time being, you should know, like, they are very similar to lists, but they have some specific properties. The way you didn't find any problem or trouble to understand tuples here, at least how they are used here, the same way here also you're not going to find any trouble as soon as you see the output here. See the output. Everything is same as in name. This thing is coming now. Name value, name key value pair. Like, see what I specified. Name as Mr. X. That's what I specified. Name equal to Mr. X. Age equal to 42. Height is equal to 5.9. Blood group is equal to A plus. This is the entire thing that I passed to this function. This function. Okay, and I printed everything as it is. From all those everything, I now picked up the blood group and I dumped it on the screen. That's what I did here. Print B of blood group. And that's printing me A plus. Correct? So it's the same way we accessed one particular element from the tuple, or the same way we can access one particular element from the list, the same way we can actually access one particular element from the dictionary also. It's like ID's dictionary, because you see, in our dictionary, we have a word, against it you have meaning, key value. Say, for example, if I say man, there will be meaning in the dictionary. Each word is a key. Against that you have these values, the meaning you can consider as values. So for example, beautiful, it will have some meaning. For example, flower, it will have some meaning. For example, art, it will have some meaning, right? Okay, now these are the different ways of actually calling a function, creating a function and calling a function in Python. Okay, and out of these two are a bit special, isn't it? I mean, they allows you to call a function with any number of inputs. Understood? Okay, if you have understood this up to this point, then you have actually learned like all different ways of writing functions. But still, there is one very important. I know the video is going a bit longer, but don't worry. This video will give you everything about functions. Is knowing everything about functions, one of the very crucial concept in Python programming language. Not only in Python programming language. Basically, it is important in any program. It is there in any programming language, and it is very important in any programming language. And it is very much similar. These concepts are exactly more or less same in all these other different programming languages also. So it worth, right, spending some time learning these functions, isn't it? Yes. Okay, so let me tell you, now we are very much close towards the end. Okay, like only one specific thing I have to tell you, and then I have to show you an example from where you'll be learning why functions are useful. I'll be coming to it in a moment, but before that, let me tell you that important thing. Okay, very important thing. And see here, from these inbuilt function examples, I brought that sign function, right? And it was, I said that there is a region, and what is that region? You see, this sign function, I could have given the example in terms of this len function also, but sign is more meaningful in this case. Now see the sign function here, or even the len function, no, don't worry about it. Now the len function here, what we do is we specify some input to the function. Up to that point it is okay, fine. Now see the difference between print, len, and sign. The difference between print and len at least is that this function, we didn't write like a is equal to print flower. Not only here, you might have not seen, never actually you have seen me writing a equal to print something, but whenever we are using len, usually we store the result in a temporary variable, or what we can do is we can pass this len of l as an input to the print function. It means what we are doing here is that we are expecting some value from the len function. Here what we're doing is we are giving this l to the len function. Okay, len, you take this l and you tell me what is the len of the list. And this len function is doing what? It has computed the len and it is returning me the value, the result. It is returning me the the length of the list. Okay, see, when you give value, we say, okay, you pass the value to the function. When the function gives the caller, like from where you have called, when the function gives that thing, we call it like it is returning. It is returning the value to the caller. So length is basically going to return us the length of the string or length of the list that we have given as input to this function. And that return value basically we store in this n. But till now, whatever the user defined functions we have written here, none of them has returned anything. If you want your function to return something, then you have to explicitly write that thing in the function itself. And how do you write that thing? Yes, you write that thing by writing the keyword. Another keyword you have to make use of, and that keyword is called as the return keyword. Let me show you an example. So for example, I write here def, and what was our sequence now? F5, F6 maybe. F6 might be there, so let me be on the safe side. F7, and what we want this function to do, okay, let me go back to this F equal to mf formula. This F7 basically does the same thing, computes the gravitational force on a mass. Say our input is f is equal to m into a, so m is one input that we have to specify. A, we want the default value to be 9.8. let everything be same. But here what we do is we compute the force also the same way, m into a, but instead of this semicolon is not needed, but instead of displaying the output there itself, that is okay, you are like giving m into a to this function, it will compute this very complex formula f is equal to ma, and rather than simply displaying the output from that place itself, what it can do is it will now return the the computed value to the caller. Now it is up to the caller what the caller wants to do with the return value. Right? What I mean by this is, now this time we don't want to print it there. What we want rather is we'll be returning this f to the caller. To the caller means from where the function was called. Okay. Now let's see the difference now. Now if I call this function f7, I have to specify like at least one input, because for one input already there is a default value. So for example, the input is 100. I could have easily write 100 comma any other value, but since it has this default value, let's say f7 100. What it will do, 100, and for a it will assume 9.8 as the default value. So 100 into 9.8 is 980.00001. okay, right, and that f will be returned to you. Return to the caller. It means when we execute this program, what will happen is this f7 first will call this function, it will execute this, it will return f, which is like 980 something. So this entire thing will be replaced by sort of 980. Okay, so as a result you will see 980 as an output here. Okay, now what we can do is the way we like stored here the return value of len in a variable, the return value of len in a variable. Where did I do that? Return value of len in a variable, and then we display the the len. Here also we can do the same thing. Say we store the variable, the result in a variable, say r, and then we can print r on the screen. Are you getting what am I saying you here? Okay, done. 980 something. But suppose, see the difference. If you're not very much like, if it, even if it is not clear what exactly this return is doing, let me write here another version of this F7 and let me call it F8, and I'll keep everything same except returning F. Here what I'll do is I'll write here print F. Okay, this F8 is like both these F7 and F8, they are there. To F7 also we give the same input. To F8 also we give the same input. Okay, but what this F7 is doing is, after it receives this input, it computes the value and it returns us the value. That is one. And this F8, what it is doing is, it is taking the same input, it is computing the value, and from that point itself it is shouting sort of, okay, I got this value as my output. It is not returning it to us. Got the analogous example? Now see the, like practically what will happen if I write R is equal to F7 this, print R, and say PQRS. S is equal to F8, and then I'm passing the same input, 100. To F7 we are passing 100, so 100 by default 9.8, it will compute 980 as the value of F, and it will return 980. So this entire thing will be replaced by 980, which will be stored in R. Print R will print you 980 on the screen. But what will happen now if I write the function this way? That is, we are calling F8 with 100, so 100 will go to M, and A is having the default value 9.8. So basically M into A will compute again the same value 980, but this F we are not returning, we are simply printing it there 980. Okay, so it is not returning anything. Since it is not returning anything, this F8 100 will be replaced by nothing, isn't it? So this nothing in Python is represented by a special word. That word is none. Okay, so basically S will have the value none, print S will print none on the screen. Let's see the difference here. So this first 980 is like coming from, see what is happening, F7 100 print R. So to make it to like distinguish this output here, I'm saying some received R, and here I write the same print statement. It should work. Received as, say, let's see the output now. Here it is saying, because I cannot, none is like, it's a type, okay, I can do one thing, str, maybe I can convert anything to string. I'm trying a lot by doing this. Still it is not float. This s is here actually is a problem. Sorry. Oh, I cannot do this thing, right? You know the reason, right? You have to convert that number to string. So now everything is fine. Now it is like as expected. This is what I was expecting. Now F7 I am calling print received string R. F7 when I call, F7 by default doesn't print anything. It computes 980, it returns 980, so 980 will be stored in R. So received string version of 980 will be displayed. So received string version of 980 is displayed. Okay, why we had to convert this R to string? Because we are doing string concatenation, right? One part is string, other part is number. It's a confusion. So we have to convert both of them to be numbers or both of them to be strings. So the simplest way is like convert the number to string, right? Okay, understood, I guess, right? And then see this other part, like we know from where this thing is coming. Then we are calling S is equal to F8 100. When we call F8 100, it goes to this function. M will have this value, A is have this value, F equal to MA computed. Then it is printing F from there itself. As a result, you are seeing this 980. This number is coming from this print statement. And then what we're doing is, like, although this function is not returning anything, we are sort of like storing the result of this function in this variable S. Since this function is not returning anything in S, none will go. That special value none will go. And here what we're doing is we are writing received, and we're trying to convert that none to string, and then received, you will get received none there. You got the point? So that is how you can make a function to return value. You see here now a function is something that can take input and also that can give you output. Input you give, you can also get the output. How do you pass input? Through this way, like by definition. In the definition you will be writing this input variable, and if you want from the function something to be returned, then you have to make use of these return statement. I guess people now got the idea, like where this return could be useful, right? So if the function is not returning, there is no point of writing something like this. But if you want to write in your program something like this, then this function must return you some valid value. Understood? Clear? Okay. If you have understood up to this point, then congratulations. I have told you everything about functions in Python. There are some other things related to function, not exactly about functions. There are some things like lambda functions. There are something called as recursion. Don't worry, I'll be discussing all those things in my coming videos, but those are nothing but simply some extension of these concepts only. Okay, so if you understood these things, then those things are just like, as I said, not the same concept, in a different format, sort of. Okay, so don't need to worry about those parts for the time being. It is now, you try to digest up to this point. Okay, then you'll be knowing everything about functions in Python. Okay, I said you basically everything about functions, but still I didn't tell you any motivation of using a function. I mean, why you should use a function? I mean, if you have to compute, say for example, what I computed here as F is equal to ma, the gravitational force on a mass. You could have done it easily by writing a program. I mean, why on earth you might want to write something like def, those extra word def, and then name of a function, input, and all this. Why you might want to do that, right? I mean, you could have easily written a program. That does something like this. Say for example, m is equal to whatever the mass, or you can even take it from a keyboard also by input statement. But say m is equal to, say this, a is equal to, say for example, 9.8, and then you can write print like whatever the gravitational force that you wanted to compute, say m into a, and that's all, right? And you might be thinking, why? You might be knowing the reason. Maybe I'm exaggerating, but still, this is a valid question, right? Why we might want to use it. Let me give you an example. From there, you will actually understand. You will immediately know, okay, I mean, seriously, that is the reason. Obviously, okay, that obvious example, let me give you. If you remember, in one of my previous video, I think just before this, in the playlist, whatever the video it is there, just before this video, you will see that I have shown you a program that prints a pattern of a triangle of stars, right? That I used to explain you the concept of nested loops, or maybe how to think like a programmer, or logic development, or whatever the reason. Okay, you don't need to worry about the logic and the code of that program. But what I'll do is I'll make use of that code here, and I'll show you the importance of functions here. Okay, for that, let me bring that code first, then I'll be telling you. Okay, this is the code that I was talking about. If you execute this code, you'll be seeing this output, right? See here, don't need to worry about the logic and all, but you should know that, okay, if you execute the code from here to here, it will be displaying you this triangle of stars. And when I say don't need to worry about the logic, I know you people know the logic. So right now, don't need to worry about the logic, in the sense you don't have to think in that direction, okay, in the logic direction. My point is that if you change now that the value of n equal to 4 from n equal to 10, then you will see a small triangle. If I write here value as 12, you will see a big triangle. That is, this number n basically decides the size of the triangle that you know. Now say for example, for our need is that we have to display the same triangle of different sizes. That's our need, say, for example, our programming need. For some reason, we have to do that. And if we don't know anything about function, then what we can do, the brute force way of doing, or the very brutal and a bad way of doing the thing is that, okay, first, say, for example, initially we need a triangle of 3 stars. I mean, 3, height, 3 rows. And we get it by writing the code in this way, and then we need a triangle of, say, five rows. What we'll be doing is we'll be copying this code, and we'll be writing here this number 5, and then again we'll be executing. We're getting it. So if we want both these, like 5 and 3 together, then we will not create another block inside the same block itself, but we'll change the value of n, and then we'll be again calling the for loop, and it will print us first the 3 triangle, and first the 3 triangle and then 5 triangle. Suppose again we need now a 10 triangle. Okay, And then what we'll be doing, we'll be copying the code and we'll be writing here, we'll change the value of n to 10 and then done. First 3, then 5, then 10, right? This is certainly working, but the thing is, see the code. The code is, if you read the code, like the same thing we have been doing again and again, isn't it? Only thing is that we're changing the value of n, then again executing the same same nested for loop, one for loop outer, and then inside that to another for loop. Basically exactly the same code we are executing. That's my point, right? Only thing is that we're changing the value of n. The length of the code is long, that's okay, fine. And also the code is like, since you have done the same thing in multiple different places, if you need to change anything about this program, then you have to change it basically everywhere. Suppose for some reason you have decided now you don't want to display these triangles, you don't want to be of stars, you want them to be of, say for example, dot. In that case, what you have to do is you have to go to like each repetitive code there, and you have to change this star to dot. You know how to do that. It is doable, but thing is that you have to do it multiple numbers of time. And suppose by mistake, it is very common human error that you forgot to actually change the one of them, and then it will produce some inconsistent output. This is just an example, okay? But this example you can, like, I think you can generalize this example to anything, any practical situation, wherever you have to do something like this, right? So here, now see, whenever you are facing a situation like this, that is a block of code, you are actually repeatedly you are writing the same block of code. It is now an indication that you should stop and think. Okay, you should write a function most probably for that block of code, because you're using it repeatedly. Okay, now let me show you how we can make use of a function, and how we can make this code more clean, clear, and concise. Okay, let's see how to do that. Okay, for that reason, by this time already, people are smart people. So what we can do is we can copy this. Okay, let's create this function here, define, and say let me call it, say for example, define triangle, tri, say. Okay, and then what I do is open and close parenthesis as part of the syntax, and then my body of the code is something like this, and this indentation I have to take care of. So I want this for loop to be there, and this part I want to like be inside this outer for loop. Okay, that much only. Okay, by default I want my function to be like this, and let's see what happens when I call this function try. Okay, let me call it here try, and this function right now doesn't take any input. Okay, so this n, it is sort of inside the body of the function itself we have hard coded to be 10, but certainly that is not a good idea. But then also the first point is we have completed the first step, that is we have created a function that generates this output on the screen. Now we can change the definition of the function, like don't consider this n to be a fixed value here. Rather than what we want this n to be is, yes, this n should be an input to the function. Now our function become more general now. Then obviously you cannot call now try without any input, because this definition of the function you have written in such a way that the agreement is such that whenever you call this function, you have to specify one input there, and that's the reason now you cannot call it like this anymore. But it's okay. It is more like common that people will actually specify here a value by default, say a triangle of 10 stars now. Okay, and it is matched with this definition, so it should give me now a triangle of 10 stars. Now I want a triangle of 3 dots. So stars I said, but it's 3 dots. Okay, and then again I want a triangle of, say for example, 7 dots. Again I want a triangle of, say for example, say 6 dots or something. Okay, now see how easy it is, just by writing this once. This code is written only once, these 2 for loops and whatever, this complex code, and then recreating these triangles are like, see, as simple as calling the function. Don't you think this code is much cleaner than this code? Finding a problem here will be very difficult, isn't it? But here it is very much easy. If there is any problem, it has to be there only within these few lines of code, because these are nothing but you just have to call the same function again and again with different inputs, isn't it? Understood? Okay, you can make, let's like, before finishing the video, let me make this triangle function more one step more general. Okay, and what more general is, let's give us make the function flexible so that we can also specify these symbols that we want to display on the triangle. Say now here, for that reason, what you can do it very easily. See this dot, instead of doing it like, instead of hard coding it, what we can do is we can take an input also. So for example, symbol S, and by default we can specify something there. So for example, by default the symbol is star. That is, if the user doesn't specify anything there, it'll be considered as star. But this dot we don't want there anymore, but what we want there is whatever it is in S, that thing we want to concatenate with a blank space there, and because we wanted star and blank, no, that's the reason. Okay, now let's see, since I didn't specify anything as my input here, by default what symbol will come? By default this star will come, so you'll be seeing stars, right? But also at the same time I can like now give any symbol there, right? Like, okay, 10 of like A's maybe, and then I want a triangle of, say for example, X's, or maybe 7 of some dots, and then maybe 6 of some what, anything, I's, okay, or O's. Let's see how O look like. Now see, these are A's, sometimes X's, sometimes dots, sometimes O's. Don't you think? I mean, it's beautiful, it's easy, and it's clear, more human friendly, all these advantages. And that is the advantage of using functions. So see, what are the advantages we got? First thing is, it reduced the length of the code drastically. One. Second thing is that it allowed us to reuse the code. I mean, we are reusing the same code, isn't it? I mean, here also we are executing the same code, here also the same code, here also the same code. Functions allows you to functions makes your code shorter. It allows you to reuse the code, and also another advantage is that it allows you to manage the code in a proper way. Finding the errors in your code becomes much easier. So if you do a mistake here somewhere, like you just realize that you want to do some change in the logic of displaying the triangle, then what you have to do is, if you don't use function, if you use this flat notation of copying, repeating the same code again and again, then if you want to do some changes in that repetitive code, then you have to do it everywhere. And when you have to do the same thing in a multiple different places, statistically, I mean, the possibilities of doing mistake is more and more. Inconsistency becomes higher and higher, right? But here there's less chance of doing inconsistent upgradation of your program, or like you have you have a better chance of reducing the errors when you make use of functions in your program. All these you can comprehend directly by looking at this example, isn't it? Okay then guys, that much only I had to tell you about functions. I have told you like what are functions, what are the different ways of writing functions, actually all the different ways of writing functions in Python, and also I showed you examples from where it should be very much clear to you like why we need functions and why we might want to use functions. Okay, you should give it a try. Next time when you write a Python program, you just try to like think it in terms of functions. See here, a program you can think of, it's a compound task. That compound task you can break down. The entire program is a compound task, but you can break down that compound task into some smaller subtasks, and those smaller subtasks you can solve using functions. That is, you can write separate functions for those smaller subparts, and then in the main program you can actually combine, or you can put all those functions in a sequence, so that executing those functions ultimately solves the problem, or it generates the output that you want your program to generate. You got the point? Okay then, so I have told you like what are functions, what are the different ways of writing functions, and what are the advantages of using functions in your program. Okay guys, then I hope people have learned something from this video. You got some value out of this video. So if you have liked the video, please do not forget to press that like button. Do not forget to share this video with your friends, and please do not forget to subscribe the channel. Thank you guys for watching the video, for giving your time. See you guys with some new content in the next video. Till then, have a nice day. Bye guys.